hypergeometric probability, right? Here's our probability formula, relatively large with many different variables involved. A being total possible successes, so how many people or things involved will give us a success. X is the actual number of successes we want to have. N being the total number of possible outcomes, so in a trial, maybe only 6 out of 100 are successful. The 100 would be our value of N. And R is the number of trials. How many times did we test this out? So let's go over our kind of word problem here. So there's 25 people at a party. Well, 25 people at a party in this question, because if we jump down to the second last part here, of those people. So in other words, they've chosen all 25 of those people. So if there's a total number of 25 outcomes, in other words, this piece of information is going to tell us that N is 25. Okay? 25 people at a party, 5 people like vanilla, 8 people like chocolate, 4 people like strawberry, and these are types of ice cream. Of those people, 6 are chosen at random. What is the probability of at least 3 preferring chocolate? Okay, so in other words, a success is called preferring chocolate in this case. So if you have to be successful by preferring chocolate, then that means the total number of things that would help us to be successful, in other words, our A variable is going to be 8 in this question. Okay? A will be 8 because there's 8 people of these 25 who do prefer chocolate. So if we draw any of those 8, they're going to say, yeah, I prefer chocolate. They also, in this question, they want to know there are 6 are chosen at random, which would mean R is our number of trials. R is going to be 6. There are 6 random trials in here. Okay? And the probability of at least 3. So at least 3 gives us quite a bit here. First of all, we're going to start with our probability of 3 of them being successful. So in other words, our number of successes, which is X in this question, X is going to be the value of 3. But because they find at least 3, we're going to have to do this question when X is 3, because there are a total of 6 trials, when X is 4, 5, and finally, if all 6 people prefer chocolate, because they told us for at least. So we're going to have to do this formula 1, 2, 3, 4 different times. Okay? So let's kind of jump down here and write it out just very quickly. N was 25. A was 8. R was 6. And X has the value of 3. And then we'll have to do one for 4, 5, and 6. Okay? So let's rewrite our formula down at the bottom here. The probability of X occurring was, what was it? A choose X multiplied by
N minus R.
Yeah, N minus R choose.
Oh, sorry, N minus A.
Oh, sorry. N minus A. Maybe we should scroll up and just bring it down. Yeah, that would be the best thing. Why don't I just copy and paste this? Since it's also neatly written out for us already. Group. Copy. There you go. Okay, so instead of having to rewrite this from memory, let's just paste it. Here we go. So here's our formula. Let's start plugging values into this formula. We'll zoom out just a little. Maybe to 100 here. Okay, so let's figure this out. Probability of event X happening is equal to, well, A is 8, so we have 8 choose, and in our first case, X is 3. And we'll have to do this several times, okay? Multiplied by N minus A, well, N is 25, A was 8. So 25 minus 8, choose R was 6, and X was 3 in this case, so 6 minus 3. So we'll have to simplify that part of the equation, and then all of that will be divided by 25, which is our N, choose R, which is 6. Okay. So you can pretty much just type this into your calculator for your combinations. What did we find when we did this?
0.21.
0.215, right? Yeah. That was for 3 guys preferring chocolate, right? And these numbers kind of simplified. We'll write it in purple here. This simplified down to 17, and that simplified down to 3. All right, so that's one of them. our next probability, okay, our A value doesn't change. We still have 8 guys who can help us be successful, but our X value does. We're looking for now at least 4 people. We're not at least, we're looking for the probability of 4 people saying that they like it. That does that. We're still going to be left with 25 minus 8, so that number's going to be 17, okay, like we had before. Those two numbers don't change. What does change is the number of 6 minus 3. It now becomes 6 minus 4 in this case. So we get 6, subtract 4, which is going to give us a value of 2 when we do that. Okay, you want to get your calculator out and test this while we're writing it? And finally, the bottom, again, is not going to change. We're still going to have 25, choose 6. So we'll write that probability out. Okay. And as you figure that out, another way we can write these probabilities is we can actually, like you've written in your book here, a fast way of doing it is they just write them on top of each other, right? The first choose the second.
Yeah.
So we're going to do that for the next two. We're going to have 8 choose 5 in the next one, multiplied by 17 is not going to change, but the bottom part is, it's going to be 6 minus 5 in this case. So we'll simplify that very quickly. And what does that simplify to?
17 and 1.
Yeah, 17 choose 1. And then all of that is going to be divided by, and again, this value doesn't change. We're going to have 25 choose 6. Okay? 6 is usually written in green. So what we're going to do is, again, we'll find out that population that's for 5 guys, and then we'll repeat the same process for 6. Okay? Probability that all 6 of them happen to be like that. And I'm going to write this all in black since we seem to have the process. 8 choose 6. This is going to be 17 choose 0 because it's 6 minus 6, all divided by 25 choose 6. Okay, so we'll pause this and find these actual populations for us. This is 6 people being successful. Zoom out just a little. Okay. Okay, so we quickly found the probabilities. For 3 guys, it was 0.215. For 4 people, 0.05 is down here, and 6. Now, because they're saying for at least, what we have to do with all of these terms is add the probabilities together, and the sum of them is going to give us the probability that at least 3 people had chosen chocolate. So when we put those together, I'll bring a calculator very quickly up. So 0.215 plus 0.0537 plus 0.00537, and finally plus 0.1231. 0.274. And is that what they got at the end there?
Yeah.
Yeah. So finally figured it out here. Probability of that happening is about 27.4% chance. And again, also, the reason we used in this question hypergeometric probability is because every time we chose somebody, depending on whether we were successful or unsuccessful in the first person chosen, the probability would change, right? And we talked about that before, so it's something